Hello, good afternoon, everyone. Welcome to Brains Mumbai 2023. We have an exciting line of events planned for you for the coming few hours. We will go through it session by session and have a quick tea break and then resume back to the other set of events. I'd like to invite Joy, who is the founder of Must Research, to give an introduction about the events lined up and share his experience.
Thank you, Jyoti, and good afternoon, everyone. So, first of all, welcome to Mass Research Brains. And this is kind of a quarterly event we conduct in multiple cities in India. And our main objective here is to promote the awareness in research and development, especially on the artificial intelligence, data science, machine learning, and all. And in Must Research, what we do, we try to bridge the gap between academia and corporate world. Because if you see, like in academia, we do have like a lot of deep research. We have a lot of work which are related to mathematics, statistics, and go deeper into the theory of computer science. Even the artificial intelligence and machine learning, we do like in-depth research. But in corporate world, we don't get that luxury time to, I mean, sometimes focus on those. And we have like some deliverables, like say the deadline is yesterday and so on. But at the same time, I mean, in corporate world, what we have seen, like the research of the applied research are there, but limited to certain R&D organization. But what we are trying to do here in Must, right, to focus on those like applications, especially in the fields which are very close to the society. For an example, healthcare, education, agriculture, retail, transportation, and so on, banking and finance. In that way, right, we are trying to understand what are the pain points. And pain points where AI can play a major role, where we can develop some solutions. So Mass Research, we started with the community development, like we who all are interested in these kind of fields, the emerging technologies, especially the AI, ML, IoT, robotics, and so on. And then later on, we started an academy as well, where we focused on very advanced level AI education. And then we finally started like AI as a solution for B2B, right? I mean, for an example, like if we collaborate with any other organization, how can we deliver some AI solution? Because there are a lot of product companies we know, and immediately some great product companies signed up with us and they requested us like, why can't we build the solutions on top of their product? For an example, Microsoft reached out to us, then Google, Nvidia, Intel, and big four companies like Deloitte, PwC, EY, and KPMG. So in that way, we started with 7 members or 7 data science and AI enthusiasts, and now we are close to 700. And I myself, like in this particular AI field for almost more than 2 decades, like 22 years now with the AI field only. And when I started my AI journey, it was not so popular. Artificial intelligence was only for, I mean, academic organizations. But now it is like very popular in the corporate world, even the common people, they are talking about it. And I really love that or enjoy that spirit. Like when someone is saying like, oh, this mobile phone has a smart camera and this mobile phone has a smart battery. I say, like, smart battery? What do you mean by smart battery? He said like this. And that guy is like just a normal salesperson and he was trying to convince me to buy a particular model. And then he mentioned, okay, based on your usage of that mobile, the battery will try to optimize so that it should not overheat or it will not burst. Nothing will happen. And then the longevity of the battery will be also higher. So like, okay, but how does it work? And that person told me, you will not understand, sir. This is called machine learning and automation. So I was so proud. I didn't mention like, okay, about my background and all, but I felt proud that now these are all common, right? They are even one auto driver was suggesting me, ये Google मैप जो है ना सर, ये ना सीख जाता है सर से। अरे how like पता नहीं जो भी लोग गलत रास्ते से जाते हैं बार-बार जाते हैं ना तो Google मैप को लगता है ये सही है तो वो सीख जाता है ये सीख जाता है what is सीख जाता है it's actually training right so machine learning the machine is being learned by user data by patterns by lot of like different signals and inputs. So these are some of the things which are really helpful. And when people are saying, like, say, just a phone unlock using face, how does it work? So all these things are related to AI. And definitely, there are a lot of applications on the healthcare domain, I mean, which are definitely, we are recently working on multiple projects, starting from cancer research to ophthalmology. So, and from that aspect, right, when we think about like how must will help India, and across the nation, when we started with 7 members and end up with 700 members, and we are trying to build that community so strong, where we can solve multiple problems which would be helpful for the society. So that's the thing of like the mass research, how it works, it operates. We have a club, we have academy, and we have the labs. So I would request the next presenters to go ahead on their particular topic. And we'll also have some cool demos today, and we'll see those. So yeah, over to you. Thank you.
Okay, so for the first set of presentation, we have Dr. Pushpa Bhattacharya. Dr. Pushpa Bhattacharya is a Bhagat Singh Rekhi Chair Professor of Computer Science and Engineering at IIT Bombay. He has done extensive research in NLP and machine learning. Some of his noteworthy contributions are Indian language NLP like Indo-Botnet, cognitive NLP, low resource NP, and knowledge graph deep learning synergy in information extraction and question answering. He has published close to 400 research papers. He has also been a visiting researcher at MIT and a visiting faculty at Stanford. With this, I'll hand over to Dr. Pushpa to give us an introduction on NLP, LLMs, and their applications.
Yes, so we are welcoming Professor Pushpa Bhattacharya, and over to you, sir.
Okay. Okay, thank you. Thank you very much. Let me share my screen. So you have to give me the permission for sharing the screen. You have to give me the permission to share the screen.
Sir, give us just a moment.
Yeah.
Yes, sir.
Okay. Is my screen visible?
Yes, sir.
Yes.
1 minute. Okay, can you just verify you are still seeing my screen?
Yes, sir, we can see it.
Yeah. Okay, so let me begin. First of all, thanks very much to Mass Research for giving me this opportunity to talk about natural language processing, our research on NLP, large language model, and various applications we have developed using these language models. I am with the Faculty of Computer Science and Engineering at IIT Bombay, and I'm sorry not to be able to come physically to the venue and deliver this talk because of some inevitable constraints. However, let's get going. Now, as the title says, I'd like to describe some of the important foundations of natural language processing, large language model, and also look at cutting edge applications, some of which are our own work from our lab. Now, before we go ahead, I would like to recite to you a poem that I wrote and which I'm quite fond of sharing with everybody. So the poem goes as follows: Ode to scientists and engineers. Scientists ask why. Engineers ask why not. Scientists wonder at what is. Engineers wonder what could be. World couldn't do without either. Scientists study, engineers make, and ever the twain shall meet. Now, the whole point of this poem is that both theory and practice are needed. Both are non-trivial, and both conceptualization and implementation are required. We need both. So theory and practice must go hand in hand. So though natural language processing is a very empirical field with huge application these days, but there are theoretical underpinnings coming from linguistics, mathematics, physics, philosophy, cognitive science, and so on. This is something we should always bear in mind. Now, a very short description of what is natural language processing. I may be risking preaching to the choir for some of you, but please bear with me because it is important to stress the foundations always. So natural language processing is language plus computation, and it is a branch of AI which deals with the study and implementation of endowing natural language understanding and generation capability on two computers. The strings understanding and generation are in red for a purpose. We have always been investigating the natural language understanding part, NLU. NLU has always got higher priority than NLG. But in recent times, because of generative AI, natural language generation has come to the center stage. And because of NLG and large language model, large number of very impactful applications have become possible. But NLU and NLG combine in a very uh, exciting way in chatbots, which have to understand the human and interactors' speech or writing, and has to respond accordingly at all levels of cognition, at the level of syntax, at the level of semantics, at the level of pragmatics, at the level of emotion, sentiment, everything. Otherwise, the communication risks breakdown. Now, a bit of history. Natural language processing is said to have been born in 1940s. Those were the Cold War days between USA and USSR. And there was a practical need to translate English from Russian and English to Russian. So to and fro translation between English and Russian. And both countries needed to understand what is passing in the form of communication from the other country, or going from the country to the other country. So there was a need for machine translation because of the volume of communication. And the problem somehow, interestingly, was trivialized. It was thought that translation involves only word-to-word substitution, and the insurmountable challenge that ambiguity poses was somehow overlooked. And this, of course, was brought home very quickly. And the ALPAC report damaged the field quite a lot, saying that machine translation is doomed to failure. But we know that is not the case. Then 1960s and 70s saw two paradigms competing with each other and running parallel to each other. This was symbolic AI versus stochastic AI, and specialized to NLP, symbolic NLP versus stochastic NLP. While the first emphasized model building from an understanding of language phenomena and the task on hand, stochastic approach emphasized the importance of data and extracting patterns from data. And we know today that the ruling paradigm is indeed data-driven, probability-driven. But symbolic paradigm also has always been a powerful paradigm, sometimes background, sometimes in the foreground. And we in particular know whenever data and resource are in short supply, symbolic paradigms have to be resorted to, at least for some time. 1970s saw the emergence of logic programming and the Prolog programming language, where the main task was to process judicial documents, judgments, FIRs, and also to do natural language inferencing, which could automatize some of the judicial process. And the forerunner in this whole investigation was Professor Kowalski from England, who himself was the designer of Prolog language. 1983 to 1993, we see more empiricism and really the reign of data, machine learning, probability, noisy channel, graphical models. These were the buzzwords during those times, solving a number of very interesting problems, but may not be at the scale that we see today. From 2010 onwards, there has been this completely overwhelming rule of neural models, deep learning network, guided by gradient descent, backpropagation. And this is the times that we are witnessing now. Now, the volume of NLP business is well known, but some figures are really mind-boggling. It is expected that by 2027, the NLP market will go to about $50 billion at a compound annual growth rate of 25.7%. This is really mind-boggling. And no wonder there is so much interest in language technology and its applications. And this is definitely caused by data, machine learning systems, and architecture also. And there are two key developments like word vectors and transformers, but we'll come back to these points a little later in the context of large language models. So this has been the guiding matrix for NLP researchers. On the rows, we have foundational NLP tasks like morphology, part-of-speech tagging, chunking, parsing, and so on. And we have cutting-edge applications like sentiment, question answering, machine translation, and so on. On the columns, we see rule-based paradigm, classical ML, and then deep learning-based systems. And under classical ML, of course, support vector machine was very successful in document classification, which can be expanded to things like sentiment classification, emotion classification. And in deep neural networks, especially in the context of multimodality, stable diffusion, VAE, GAN, they have been very exciting techniques and have been used widely. Now, coming to some really foundational points, there are two pillars on which the whole structure of NLP rests. And it will be harmful in our interest not to give importance to both the pillars. Though one of the pillars gets pushed to the background, but that would be harmful to the development of the field. So, of course, at the end of the day, we need a coded natural language processing system which solves some useful task. But this coded system, if we look closely, we'll see rests on two pillars. One is linguistics, the other is probability. So language science and data science. Where does linguistics play its role? It plays its role before and after ML. So a machine learning model has been trained, and before the machine learning model is trained, we need annotated data. Annotation on the data is possible only if we have linguistic insight. Everywhere, like creation of tree bank, part of speech tag data, sentiment data, emotion data, bias data, everywhere we need a very thorough understanding of language phenomena and task phenomena. To give you an example, and which is a food for thought for everybody, in English, the whole part of speech tag repository is now primarily the pen tree bank tags. Now, in that tag set, all prepositions are grouped under a tag called IN. So in is the representative of the part of speech tags for prepositions. Curiously, one of the prepositions, to, is separate from this whole set, and it is given a separate tag, capital TO. The curious question is why so? Why should to get a different treatment than its counterparts, namely the other prepositions like with, by, in, at, and so on? So that's a very intricate linguistic and machine learning question. If we do not separate to from the rest of the tags, the accuracy falls quite drastically, of the accuracy of pause tagging, and that affects chunking, parsing, semantic role labeling, all the downstream tasks. And this was a deep insight from linguists to see that to needs a special treatment, mainly because in English, almost all nouns can act as verbs. And also, the third person singular number present tense has the same form as the plural form. So plays can be third person singular number present tense or plural of play when it is a noun. Then after the ML model has operated, for error analysis, again, we need deep linguistic insight. Otherwise, any kind of progress on the model building is quite blind and unguided. Similarly, we need insight from data science, which is epitomized by the use of probability. We know that softmax scores give rise to a decision-making framework, whereby the class with the highest probability is given as the result of prediction or inferencing. Now, two laws, or one theorem, another is a law, which are always at the background, providing the theoretical confidence. The first is law of large numbers, and the second is central limit theorem. The whole of hypothesis testing, test of significance, rests on central limit theorem, and law of large numbers gives us the power to trust probability values when we obtain those probability values from a sufficient amount of data. So data science and language science both are critical to natural language processing. Without either of them, the field actually languishes. Now, natural language processing, what is the main challenge? The main challenge is ambiguity, especially when we implement NLP algorithms on computers. So here are two interesting examples of ambiguity coming from COVID days. So they both were headlines in Times of India during COVID days. The first sentence, elderly with young face increased COVID-19 risk. So this pause is very critical. And we know that in communication, both utterances and pauses play important role. So the meaning is old people with young children are more vulnerable to COVID-19. But if you place the pause at a wrong place, elderly with young face increased COVID-19 risk. In this case, increase becomes the main verb, and it has a very strange meaning, as if old people whose faces are young are responsible for increasing COVID-19 risk, which is a very strange meaning. Similarly, think about this sentence, Maharashtra reports increased COVID-19 cases. If you join Maharashtra and reports together to form a multi-word, and increase becomes the main verb, again, we have a very funny meaning. Now, ambiguity can be lexical ambiguity and structural ambiguity. Lexical ambiguity is ambiguity of phrases and words. Structural ambiguity is ambiguity of attachment. So this is a humorous conversation and arises from the Grecian maxim of violation of relation. Maxim of relation is violated. So this lady talks to her dog saying, the neighbor tells me you are chasing people on a motorcycle. And the dog says he is lying. I don't even have a motorcycle. So who is on a motorcycle is the question. And that arises from what is called PP attachment ambiguity. And the lady's world and dog's world do not intersect. This is a situation of incongruity, which leads to ambiguity, and that leads to humor. So ambiguity is really ubiquitous. You see them everywhere. I was listening on 29th March to a Vivid Bharati program. And a lady gave this example of ambiguity again. Aaj karyalay band rakha jayega. Today the office will remain closed. And if you change the segmentation a bit, Aaj karyalay bandar kha jayega. Today the office will be eaten by monkey. So this kind of wrong breakage of words can lead to very hilarious situation. Korea leave Uruguay in tears. This was a FIFA news. Question is, who was in tears? Uruguay is a place or team. What does leave mean, go or cause? So ambiguity is the main challenge in natural language processing, and it happens at every layer of the so-called, the famous NLP stack, starting from morphology to pause tagging to chunking to parsing to semantics, discourse. Everywhere, ambiguity can really pose challenges. And the role of machine learning, probability, and data is to supply disambiguation signals. And this is done by training a neural network or a classical machine learning system, or we create rules for disambiguation at every layer of NLP stack. Now, our lab called Center for Indian Language Technology in IIT Bombay has been active in natural language processing since 2000. We have been generously funded by government, industry, and we have been able to contribute to science and technology, created many resources with Indian language in focus, which have been found useful by research groups all over the world. We have worked in machine translation, information retrieval, sentiment analysis, almost all field of natural language processing. Some of the innovative developments from our lab has been cognitive NLP, for example. where we capture eye tracking signals, EEG signals, muscle signals, and those are added as features to a machine learning model, whereby the accuracy of the ML system increases. Now this finishes the first part of my presentation. I just want to make sure that I am audible and my slides are visible. And at this point, if there is any question or comment from anybody.
Sir, we are able to hear and you clearly, and slides are also very well visible. I'll just take a moment to ask if there's a question around.
Yeah.
This is on the last language.
Sir, please continue. Probably we'll have.
Continue. Okay, maybe later at the end, maybe. Yeah. So we come to the developments of large language models these days and a bit of comparison across different famous LLMs. Now, large language models are now everywhere. Machine translation uses LLM. Question answering definitely uses. So ChatGPT, to use a very often used cliche, ChatGPT is taking the world by storm. Then Grammarly internally uses large language model as writing aid. And in multilingual situations like image captioning or generating images from text, for example, in DALI, we see the use of large language models. Now, large language models are actually simplicity itself. Internally, they do one thing extremely well, and that's a very, very simple task. That task is to complete a sequence of words by the next word. I like pizza with loads of. The most expected word there is cheese. Corn is maybe a little less expected. Tree is not expected. So for tree, the probability value is really low, 0.02, corn 0.46, cheese 0.75. Please do not try to add these numbers. There are some scores. They have to be normalized to convert them into probability values. But all it says is that the probability of cheese as the next word coming after these n words is high. And that is the task of language model. It must predict with high confidence the next word, and the score is based on probability. So this in large language models, the difference between an ordinary language model and large language model is that the large language model has very long window. Maybe the next word is predicted based on 4,000 words. And 4,000 words is almost capturing every conceivable concept that can appear in speech, text, or whatever be the situation based on communication using language. So these long contexts are actually the source of power in large language model. But the task that they do is absolutely simple. Just predict the next word based on a sequence of words. Of course, one might come back and say that why next word? There are also what are called masked language models, which can be looked upon as filling the blanks. But they also essentially are capturing the forward and backward context. And based on that, giving a probability value for the word which is missing. Now, in that process, the neural network strengthens itself or arms itself with a very useful set of parameters. Now, the situation is like an athlete who has high level of stamina, agility, and is good in using the body. So such an athlete can do well in any sports: swimming, tennis, football, cricket, any sports. So large language models are this. In being able to predict the next word very, very well, they build their strength or set their parameters such that this set of parameters become useful for any language processing task. So that is the beauty of language models. And language models initially were simply probabilities of strings of words which were computed from a large amount of corpus. These gradually gave rise to a continuous representation of words, namely word vectors. And word vectors gave rise to sentence vectors and also completion of words with the words can be at the end of the sentence or within the sentence. And this kind of prediction required training parameters. These parameters were then found to be useful for any downstream NLP task. So that is the whole theory of language modeling. Of course, there are language models which are based on grammar. Okay, context-free grammar or probabilistic context-free grammar are also language models. They are also theoretically very interesting. But practically speaking, and in terms of the sheer computing power, the modern language models based on vectors and next word prediction are actually the most powerful paradigms now. Now, two most famous LMs are InstructGPT and ChatGPT. InstructGPT does not remember its context. A command or a request is given, and the InstructGPT responds without reference to what happened before. ChatGPT, on the other hand, maintains the context, and therefore it also solves the problems of ellipses, anaphora, referencing, cohesion, coherence, and so on. We are all struck by the remarkable coherence and cohesion in the output of ChatGPT. Even if it is hallucinating, the whole thing seems so coherent and cohesive. Okay, so this happens just by virtue of this long window, a large language model, namely the prediction of the next word. So it is also able to capture conversation and nuances to a large extent. So for example, if the input is, I have been promoted, the appropriate response is, I am delighted, congratulations, great. An inappropriate response would be, why did they promote you? So that can happen through some kind of bantering between two friends, but that is not the canonical response. So these kind of abilities are seen in ChatGPT very well. And smaller language models are like BART, XLM, Muril, Indic, BART, BioBART, and so on. So we do see this very useful trend of creating language-specific, domain-specific, task-specific language models, which are extremely efficient at solving some of the task-specific operations. Now, two pillars of transformers, which are based on this idea of language model, are attention and positional encoding. So RNN giving rise to LSTM and YLSTM were the ruling techniques for quite some time. Then in 2017, we see the emergence of transformers. Transformers are stacks of computation blocks in encoder and decoder. And only encoder, only decoder, they have been found very, very useful for various NLP tasks. So only encoder is BART, for example. Only decoder is GPT. So these are very useful instruments for language tasks. Here also a look at the chronology of events would be useful. IBM models came in 1990s, and they solved the problem of alignment of words from parallel corpora by using expectation maximization. So these actually unraveled the power of data, showed that a completely new paradigm has emerged suddenly. Then phrase-based MT was very successful for many different languages. Encoder-decoder came in 2014, and attention was proposed in 2015 by Bahadanu. Finally, in 2017, attention plus positional encoding was used to create the transformers, and today's world is completely ruled by transformers. So transformers are at the heart of large language models, and the number of parameters are extremely large. Now we all know that generative pre-training, supervised fine-tuning, and reinforcement learning based on human feedback, which is purely controlled by AI trainers. These are the stages of any large language model. So everybody has been interested in comparing chatbots like BART, Bing, and ChatGPT. We ourselves also, investigate into these questions. But this blog became quite famous because it carried out an incisive comparison of BART, Bing, and ChatGPT. It is slightly old. Maybe it came out in March, I believe. But some insightful things are reported there, which I can briefly mention. So a range of questions were asked to these chatbots. Common requests like from holiday tips to gaming advice to mortgage calculators. And the summary from the blog is that ChatGPT is the most verbally dexterous. Bing is best for getting information from the web because Bing can query the web. ChatGPT is not allowed to. And Bard was still evolving at the time. At the time of going to the press, Bard is now also multimodal. It can process images. So OpenAI's ChatGPT uses GPT-4. Bing is also GPT-4, but Bing has other abilities like generating images. Now, OpenAI, we know, has also plugins for computation, plugin for consulting a calendar, and so on. Now, the blog reports that when asked about the recipe for chocolate cake, ChatGPT did extremely well because there are many variations possible on the recipe for cake. Shift around the ratio of flour to water to oil to butter and sugar to eggs, and you will get slightly different versions of your cake. So ChatGPT chose a chocolate cake recipe from one available, buttercream recipe from another, shared the link for one of the two, and reproduced both their ingredients correctly. It even added some helpful instructions like suggesting the use of parchment paper. So ChatGPT was best in terms of a recipe for food items. Then for technical questions like how do I install RAM into my PC, all the chatbots were at the level of novice technicians. They, for example, missed crucial information on BIOS setting afterwards, AMD's equivalent, and XMP compatible RAM, and so on. But they gave a kind of preliminary help, which was at the level of novice technician. Writing a poem, ChatGPT beat everybody hands down. So this was a non-trivial poem writing exercise. Anapestic tetrameter, a poem about a worm in anapestic tetrameter. And the rhythm goes as follows. It was the night before Christmas when all through the house, not a creature was stirring, not even a mouse. So that is the kind of rhythm. And it actually reproduced that rhythm. And we all know how good ChatGPT is in writing poems in any style, for that matter. Question answering was, again, very good in ChatGPT. When it came to basic maths, none of the chatbots were good, but GPT-4 was consistent because it was not changing its answer when asked to regenerate the answer. So that would actually lessen the confidence in any maths teacher. If the maths teacher, when questioned, changes the answer every time, that is not a happy situation. Then for information like what is the average salary for a plumber in New York City, Bing was best because it could query the internet and it could cite sources like Zofia, Career Explorer, and so on. ChatGPT gave a ballpark figure, explained that there were caveats, and told about what sources one could check for more detailed numbers. Designing a training plan to run a marathon, in the ChatGPT was the winner by many miles. Bing inked out a Runner's World article that isn't necessarily an irresponsible decision. So it just produced a manual without giving the recipe for running marathon. Holiday tips, all the three chatbots were very good, and they also suggested what to avoid in the city of Rome, because there are all kinds of shady characters there. Testing reasoning, the puzzles were presented to the ChatGPT. It's a long text. I'll not go through it, but I myself gave it a small puzzle where there was the story of a captain who becomes shipwrecked. He stays on an island for a long time, tries to cook some potato, and in the process, because of the heat which was available, the sand below the fire turned into glass. And all the time, the captain was looking into the sea through his binocular to see if he could spot a ship. And the ship finally rescued the captain. So clearly, there is an inconsistency in the story. If you're using a binocular, how come glass gets discovered through his effort of cooking? Okay, there is an internal inconsistency. But ChatGPT did not catch that inconsistency. It went to history, which was the data available to it for training, and says that firstly, glass was not invented by a shipwrecked captain as described in the story. The history of glassmaking goes back thousands of years. So it is making historical remarks and trying to say that the story has historical inconsistency. But the fact that even if there was no historical inconsistency, the story has its own internal inconsistency that ChatGPT could not catch. Anyway, so while regenerating the response, also it kept going back to history and not was able to spot the internal inconsistency. So now I move to our own work on application of large language models in two applications. So first is automatic radiology sonology report generation from dictation of the radiologist and from image. So they have been reported in top conferences. Now the motivation of this work is very well founded. Radiologist to patient ratio in India is 1 in 100,000. Corresponding ratio in USA is 1:10,000, and China is 1:, about 15,000. So this results in very high patient inflows, making the radiologist incredibly busy and stressed out. The typical process is this: the radiologist looks at the plate, gives a dictation. The transcriptionist takes the dictation, consults a template report, makes necessary changes, gives the report to the radiologist, and there can be back and forth transfer of this report between the transcript and radiologist until it becomes perfect, and then the final report is produced. This typically takes 2 days, and in many countries, I'm told the report generation can even take 7 days. So this is the process which needed automation, and I got a fellowship called Abdul Kalam Fellowship in 2020. And this is a very translation-oriented fellowship because the research must produce some impactful, useful system. So this fellowship supported this research, and we have worked with a startup in Mumbai, and they have an office in London too. So here the startup is called Ognito. They have a very high quality ASR where the sonologist dictation becomes text. Now this text we take up and consult a knowledge graph, biological knowledge graph, and also the reports which are available in the as template in the database. So we take a normal report and convert it into the patient specific report. So here we need both deep learning and knowledge graph. We created the knowledge graph of 12 abdominal organs, including spleen, stomach, intestine, liver, and so on. And the problem statement is that radiologist dictation is the input and a radiology report, which is patient specific, is the output. Now, in this process, we had to solve a very important problem of constructing the knowledge graph of abdominal organs with help from the doctors. So the radiology free text corpus was taken, and the corpus looks like this. It has various segments devoted to different parts of the abdominal area: liver, gallbladder, spleen, pancreas, and so on. And when a patient-specific report comes, this is the template where necessary changes are made in the text and the report is produced. So this whole process has been automated, and we have given the system to our partner where they are testing it in various hospitals of Mumbai. And I think the feedback so far is positive. So some example, radiologist dictation is chronic pancreatitis. Pathological description, which is a more elaborate and medically correct description, is pancreas is slightly small, reveals thin inhomogeneous parenchyma. The pancreatic duct is dilated. So this is a medical description. And our task is like a machine translation task. Take the dictation and convert it into pathological description. We got large amount of parallel corpus from our startup partner who are in this field for a long time. And we from IIT Bombay supplied to them all this help on NLP, ASR, and knowledge graph, and so on. So the knowledge graph is in this form. Upper abdomen has all these entities like neck wall inflammation is a state, cholecystitis is a malady in the organ, and so on. So this way the knowledge graph is created, and this knowledge graph does knowledge infusion into a deep learning network. So the deep learning network is trained with the parallel corpus of dictation and pathological description. Here is an example of a liver ultrasound knowledge graph. We create a preliminary knowledge graph from the corpora through information extraction and NLP tools, and then the doctors vet it, modify it, update it, after which it becomes a high quality knowledge resource. And the technique, of course, is standard. It is based on BART, which itself is a language model, supported by the input concept graph, the concept expansion graph. If the dictation is grade 1 fatty liver, the system produces liver shows mild echo texture, which is a medically correct description. So this was also compared with some state-of-the-art systems, and our numbers, which are shown in the last row, show that we have an accuracy of about 90% in terms of blue score, rule score. And this is a good system which the doctors are now saying can be a useful tool when taken to the field. We have done extensive error analysis also on the system. For the sake of time, I'm not going into those details. Span identification picks up the sentence, which is the target for replacement for the patient. And the pathological descriptions are also classified into different categories. Kidney 5, for example, means that this statement is about kidney, but on a particular aspect of kidney, the fifth aspect of kidney. So all this has been turned into a tool, and the tool takes the input from the radiologist, the dictation, for example, chronic pancreatitis, and produces a report eventually. So this was one of the applications which we believe will be quite useful to the society, and in the healthcare area should be a useful tool to use. And in about next 5 or 10 minutes, I would like to go into another very interesting application which we created this time and was reported in ACL 2023. So conversational AIs or chatbots, we see increasingly they need to be empathetic, and otherwise the business interest gets harmed. So there was a 2015 report from Harvard Business Review, which had this global empathy index. And they had this statement: there is a direct link between empathy and commercial success. Businesses are more profitable and productive when they act ethically, treat their staff well, and communicate better with the customers. So this we have seen in our interaction with various agencies also who approach our lab for sponsored and consultancy projects. So they say that their chatbots need to become more polite, more empathetic, and otherwise they seem to be at a disadvantage compared to their competitors. And Harvard Business Review in 2015 also brought out a list of organizations ranked according to their global empathy index. So LinkedIn topped that list. It was in 2015, quite some time back. And these kind of lists keep getting produced by management consultancy companies. So Nike was at the 8th position, Google was in the 7th position, and so on. So it is a practical fact that chatbots with empathy and understanding of emotion would score over other chatbots which are employed by their parent organizations. Now here there are important philosophical, linguistic, and cognitive science theoretical framework which are at work here. So for a conversation to be sustained, 4 maxims have to be satisfied: maximum of quantity, quality, relation, and manner. I don't have time to again elaborate these maxims. Quantity corresponds to the presence of exact amount of information, not less, not more. Quality is truthfulness and sincerity. Relation is relevance. And manner is the manner in which the response is given. So manner is very interesting. So if the question is, do you know where the IIT Bombay library is? And if the answer is yes, I do, it is near the maths building. This is a simple, direct answer. This is nice. However, there can be violation, and it can give rise to very interesting effect. Up yonder in the citadel of learning, where polynomials are the bread and operators are the butter, and where Hardy and Ramanujam permeate the atmosphere, thither will define the storehouse of what bibliophiles love. So it is describing where the library is, but library is being described in a very colorful way, what bibliophiles love. And near the maths building, maths itself is also being described in an indirect but very interesting way through metaphors and so on. Polynomials are bread and operators are butter. Hardy and Ramanujam permeate the atmosphere. This is what happens in a maths environment. So ChatGPT also was given this question and answer. I gave this question and answer to ChatGPT, and it could say that based on the answer given, it seems that the person is using figurative and poetic language to describe the location of library. They are painting a vivid picture of library. So these things were spotted by ChatGPT. But it also suggests that the answer may not be helpful if the person asking the question simply needs a straightforward answer. So ChatGPT can distinguish between metaphor and direct answer. So that takes me to our work, and this is the last part of my talk, which was reported recently. We could understand that hyperbole and metaphor go hand in hand. Whenever people use metaphor, they often use exaggeration, which is hyperbole. And these two language phenomena almost always coexist. So why not do them in a multitask manner? So this sentence, the principal is angry. This is a simple direct statement. The principal is going to cook us is both hyperbolic and metaphorical. Now, hyperbole metaphor need to be understood by the chatbot. This is from the data, but I don't know if it is inserted hypothetically or it is an actual conversation. The chatbot asks the human being, "How was your day?" And the human conversationalist says, "It was raining profits today. Oh, remember to take an umbrella next time. I made a ton of money. That must have been heavy." Sigh, the human being gives up. So chatbots need to understand sarcasm, need to understand metaphor, hyperbole, because that is the demand of the times. Now, this is not a fictitious circumstance completely. If we utter Lumos Maxima in front of Google Assistant or Siri, then that turns on the smartphone flashlight. This utterance is, by the way, metaphorical, coming from Harry Potter. So multitasking is definitely very useful in many situations. So this is an example of a spoon and fork together. This is called a spork. So many times two tasks being performed together give rise to increased performance for both tasks. So we employed this architecture for simultaneous detection of hyperbole and metaphor. The encoder takes the text and passes the vectors to the classification head through a number of layers, transformer layers. Metaphor and hyperbole are detected together. So we took standard data from existing in the field, added our own embellishments. So therefore, it was a contribution from the data's angle too. And our numbers on three standard data showed that we are scoring over the state of the art. Okay, and also we have given a new benchmark for hyperbole detection through our work. So we have also done qualitative study, and we do see that we are doing well in terms of various case studies also compared to the single task mechanism. So if the sentence is "hope deferred makes the heart sick," books are food for avid readers. So books are food for avid readers is definitely a metaphorical statement. Food here is a metaphorical construct. We do say that our system gives more attention to food compared to the single task system, as is evidenced by the color coding here. This is like a heat map. Now, here is a summary of what I discussed. We discussed the nature of natural language processing. And ML is useful because it does ambiguity resolution. LLMs have become ubiquitous, but they do actually one very simple thing extremely well, namely the prediction of the next word, and thereby obtains very useful values on their parameters. Depending on the resource availability, we go from lightest framework to heaviest. The lightest is LLM plus prompts. Next heavy is adapter. Next fine-tuning, and finally pre-training. Pre-training, not everybody can do on billions of parameters with trillions of tokens. It is not in everybody's capacity to do pre-training. But pre-training models can be fine-tuned with the task-specific data, which is lighter, and much more lighter is adapter, where you have only the final feed-forward layer to be trained. And comparison of ChatGPT with other chatbots shows that it is currently performing the best. in terms of its output, syntactic, semantic, construction of sentences. It is doing the best, but it is handicapped because it cannot query the internet, and also the data is up to 2021. But all these things are changing very, very promptly. I'll give some demos. Some of the conclusions are NLP and language. NLP is language plus computation, in particular linguistics and probability combined. Knowledge, logic, data, learning are the fundamentals. Noisy channel, gradient descent, backpropagation, deep networks are foundational techniques. And we know that deep learning succeeds with data, and that actually is the caveat too. And if we do not have data, then we have to make use of feature-controlled classical machine learning. And if we have no data at all, then we have to resort to zero or few shot training, meta learning, or we have to sit down and create rules. So we also have investigated rare language phenomena like sarcasm, metaphor, hyperbole, and they are no longer idealistic tasks. They are practical needs in conversational AI. Application of sentiment, emotion, and mental health space is something we're investigating quite seriously. Can we make use of a mental health patient's communication and predict if there is any disaster looming in the horizon? Then we can take necessary steps to bring the person back from the brinks, so to say. Generative AI is here to stay, and many innovative applications are possible. So let me quickly go to two small demos. So one is our metaphorical system. So suppose I give the sentence, John who works hard all day with tremendous energy is a ball of fire. So the metaphorical phrase here is ball of fire. This should give a high score for hyperbole and metaphor. Let us see, but it takes about 20 seconds. Meanwhile, let me demonstrate to you our language model-based speech-to-speech and text-to-text translation system. So the workshop is called Brains. So let me give some sentence pertaining to brain. Brain is the seat of intelligence and cognition.
मस्तिष्क बुद्धि और ज्ञान की सीट है.
Was the translation audible? Spoken translation?
Yes, sir. Audible.
Audible. And if I take this Hindi sentence and take it to our text-to-text system, Hindi to Marathi. मस्तिष्क बुद्धी और ज्ञान की सीट है. मेंदू हा ज्ञान आणि बुद्धीची जागा आहे. That is Marathi. And if I turn this Marathi to English, back to English. The brain is the space of knowledge and wisdom. So original sentence was, brain is the seat of intelligence and cognition. We have got back through Hindi and Marathi the sentence, the brain is the space of knowledge and wisdom, which needs a little bit of post-editing. But we are doing pretty well in terms of performance particularly two domains, tourism, health, and judicial also. So three domains we're doing very well. We're interacting with high courts for adoption of our system for their transition need. Meanwhile, let's check what happened to this metaphorical sentence. John, who works hard all day with tremendous energy, is a ball of fire. We see that the single task system, which detects only hyperbole, says that it is a hyperbolic statement. There is exaggeration. And multitask system gets better accuracy than single task system, 0.997 as opposed to 0.972. And metaphorical score is also very high, about 1. Ball of fire has been attended to by both systems, but our system, the multitask system, makes this phrase ball of fire extremely dark, which means a lot of attention is paid to this particular phrase in detecting that the sentence is metaphorical. So So with this, I will end my talk, and thank you so much for your attention.
Thank you very much, sir. That was a very informative talk. I'll just ask around if there are any questions.
Yeah.
Okay. All right, sir. Thank you very much.
Thank you very much.
Thank you for your time. Thank you for the talk.
Right, thank you for having me.
All right. Thank you. Okay.